Welcome to class 10th quadratic equations. Okay, let's learn quadratic equations and solve all the problems related to the quadratic equations. I am taking reference as a Telangana class 10th maths book for the quadratic equations. We will all the theory part we will learn from this one and then also solve the ICSE book. Okay, and I am having another series of videos where IOQM level problems. The same thing is polynomials and quadratic equations is ongoing. You can check those videos also for more learning. Let's get into the quadratic equations. Okay. In this video, we will learn these topics. What are the quadratic equations? Some exercises, then solutions to the quadratic equations by different methods. One is factorization, then completing the square, and nature of the roots. Okay. Then we solve all the exercises and optional exercise. Introduction. Okay, as I said, we will be following the book from the Telangana class 10th mathematics book. Okay, this is the chapter 5 in the quadratic equations. Okay, so let's take some real life situations. You have a sports committee, okay, of a high school and then wants to construct a coco court. Okay, the coco court dimensions you might know already, some of you who are playing coco. 29 meters width, okay, and 16 meters, 29 meters length and 16 meters width, okay. This is the court we want to build in an area of 558 meters square. This whole area is 558, okay. So this is the, okay, this is the coco ground dimensions, and this is the total area of the ground, okay. Now you want to leave a space of equal width around this. The width should be equal, so let's call it x, okay. Then how do you solve this problem? This is very simple. We know that coco court is 16 meters by 29 and you are leaving a width of x, x, okay, all the sides. So the total area 558 meters square, okay, should have a length of 29 plus 2x meters and 16 plus 2x meters, correct? So if you multiply these two, that is the area, right? Length and breadth, okay. So the area of the rectangular plot would be 29 plus 2x into 16 plus 2x, length and breadth, which is equal to 558, okay. So this is the equation, that's what we derived, okay. Now we need to solve this equation. So first thing is we will do is expand the equation. What you will get is 4x square plus 90x plus 464 equal to 558, okay. This is the equation, okay. And then finally this is the quadratic equation what we get, okay. What is the definition of quadratic equation? As you know from the previous chapters, okay, the highest power of x, okay, variable should be 2, okay. Then it is called a quadratic equation. In this case we have a 4x square where x power is 2, right? So this is a quadratic equations, okay. You can simplify by dividing with 2 on both sides. This is what you get, okay. So linear equation is ax plus c, as we learned in the previous chapter, okay. uh, Similarly, quadratic equation is ax square plus bx plus c, you will get equal to 0, okay. Let's see another example and see how quadratic equations will help in getting to a equation first, okay. First let's put the problem in the equation, okay, then we will solve it. So here is what we did. We put the given problem in a equation, quadratic equation. Let's do another problem then, okay. Another example you'll see. Rani has a square metal sheet, okay, it's a square metal sheet. She removed squares of side 9 centimeters from each corner of this sheet. Of the remaining sheet, she turned up the sides, okay, to form an open box as shown here below. The capacity of the box is 114 centimeter cube. Can we find out original dimensions of the metal sheet? Okay. First, let us derive the equation. She has a metal sheet, okay, and she has cut 9 centimeters from the corners, okay, 9 and 9, okay, a square, okay, she cut it, and then she folded it up, okay. So obviously length is 9 centimeters, because this is the length it will become when you fold this up, okay. 9 centimeters is the height, sorry, okay, and the length and width will be x minus 18 here, x minus 18 here, correct, x minus 18, x minus this is cut, right, this is cut. So only remaining is bottom is only this x, okay. So the dimensions of the box are 9 into x minus 18 into x minus 18, correct. This is the uh, total capacity of the box, basically volume of the box, okay. The volume of the box is 144, that is given, so these three will be equal to this, okay. So you basically simplify it, and then this is the quadratic equation. What we will get: x square minus 30x 36x plus 308 equal to 308 equal to 0. So this is also quadratic because x to the power is 2, okay. So this is the equation we derived from this given problem, okay. So first thing we should know is how to bring into equation from the given problem, okay. Once you know how to get into the equation, either linear equation or quadratic or any other polynomial, we can solve it, okay. So these are all quadratic polynomials. Yes, I said, because as I said, we should have the the variable power, highest power of the variable should be 2. Then it is called a quadratic equation. Here x square, right? So it is in the form of ax square plus bx plus c. Okay, where a is not equal to 0. This is most important. Okay, you can call it quadratic if you have power 2. Okay, if a itself is 0, that means you don't have x square term, then you cannot call it quadratic. It will become a linear equation or just a constant term, okay. Okay, so the definition of quadratic equation is here. We know it from the polynomials itself, okay. It is in the form of x square plus bx plus c equal to 0, and a, b, c are real numbers, and a is not equal to 0. This is the formal definition, right? So example is, this is one example, and several other examples are given here, okay. Okay. If the equation is in the form of px equal to 0, where px is a polynomial of degree 2, it's a quadratic equation. Yes, it is written in terms of p of x in the descending order of their degrees. Okay, we normally write power 2, power 1, and power 0. Okay, this is the normal standard way of writing. So if you want to represent as a function, then y equal to r p of x equal to x square plus ax square plus bx plus c. Okay. Check whether the following equations are quadratic equations or not. Okay. Let's see. This is the quadratic equation, right? There is no doubt x to the power is 2 and all are real numbers. Okay, fine. This is not a quadratic. This is cubic equation actually. Power 3. X to the power is 3. This you can call it a quadratic equation. You can bring 7x to the other side. It will become 2x square minus 7x equal to 0, which is a quadratic equation. Okay, this is not quadratic because if you simplify it, basically multiply this whole equation with x to the power of 2 x square, it will become x power 4 plus x square equal to 2x square, right? So this is not quadratic, okay. And what about this one? Okay, by looking at, we should be able to tell. We can easily expand it and write, okay. If you see here, x into x square is there, term is there, and this is 6x square, correct. It is a 6x square. And what about this side? X into x is there, x square into bx square, okay. So it is 6x square minus bx square, okay. B is not defined, okay. B is a constant term. If b is a constant term, then this is a quadratic equation. You have x square term, it is not 0, but it will be a quadratic equation only if b is not equal to 6. If b is 6, what happens? You have 6x square this side, LHS side, and B, if B is 6, you have 6x square on the RHS side also. Both gets cancelled. Then it is not a quadratic equation, right? So this is the quadratic equation if and only if B is not equal to 6. That is the condition. Okay. This is a quadratic equation. There is no y power 1 term, but it's a quadratic equation. 3y square minus 192 equal to 0 is a quadratic equation. Okay. Now let's see various situations described by the quadratic equations. When a rocket is fired upwards, then the path of the rocket is defined by a quadratic equation. It is more of parabolic equation. So parabola is, if you represent a quadratic equation in a graph paper, it will looks like a parabola, basically, right? So it's a quadratic equation. Shapes of the satellite dish, okay, you can see here, right? Curved, okay. Reflecting mirror in a telescope, lens of the eyeglass, and orbits of the celestial objects are defined by the quadratic functions. These are all defined by, if you represent them in equations, you have to represent all these by quadratic equations. The path of artificial satellite or Earth movement around sun, these are all will be represented by quadratic equations. Another obvious example, which in physics you will see, uh, projectile motion. Basically, you can represent in a quadratic equation. Okay. When the brakes are applied to a vehicle, the stopping distance is calculated by using quadratic equation, right? So what is the equation? If you remember your physics class, S equal to ut plus half at square, correct? In time, you have ut plus half at square. Okay, so there is a t square, there is a t term, and there is a constant term which is s. Okay, so that's a quadratic equation. Okay. Now next, represent the following situations with the suitable mathematical equations. These are all examples we will learn. First, we should be able to convert the problem into an equation. That is the first step. Once you are very good in that, we will go for solving those problems. First, we will convert into equations. Sridhar and Rajendra together have 45 marbles. Okay, let Sridhar has 45 marbles, we'll say. Then both of them lost 5 marbles each. Okay, both of them lost 5 marbles each. The product of the number of marbles they now have is 124. Okay, the product of the number of marbles they have is 124 after losing 5 marbles. Okay, so let Sridhar has x marbles, then obviously Rajendra marbles are 45 minus x, correct? Because total is 45. Okay, the number of marbles left with Sridhar when he lost 5 marbles is x minus 5. Similarly, number of marbles left with Rajendra after he lost 5 marbles is 45 minus x minus 5, which is 40 minus x. Now product of these two, okay, product of these two is 124. That's what is given, right? So we will write a equation like this, okay? And simplified, what you will get is minus x square plus 45x minus 200, which is equal to 124. Okay, so you take the constant term to one side. This is what the final simplified equation, and this is a quadratic equation because it has a x square term. Okay. Okay. Now, so other one, second problem example. The hypotenuse of a right triangle is 25 centimeters. That's written here. Okay, in the picture you can see. We know that the difference in length of the other two sides is 5 centimeters. Find the required quadratic equation to find out the length of two sides. Okay, this is 25. Let's call one of the side as x, then other one will be 5 plus x because the difference in two sides is 5 centimeters. Now we know the Pythagoras theorem. As per Pythagoras theorem, x square plus x plus 5 whole square equal to 25 square. Correct? Just to simplify it. Okay, simplify this, what you will get is x square plus 5x minus 300 equal to 0. This is the quadratic equation we will form. Okay, so to solve the quadratic equation, you don't need another equation. You can solve this one. We will see those how to solve the quadratic equation in the next sections. Okay. Right now our interest is to form the question. Take a question, try to form the equation, and try to form a quadratic equation. Okay. It can be quadratic, it can be linear, it can be some other polynomial. We'll try to form the equations first. Okay. Check whether the following are quadratic equations or not. Okay. So the first one is x minus 2 whole square plus 1 equal to 2x minus 3. So obviously this is a quadratic equation. From looks we can tell easily because there is a x square term here on the LHS side and there is no other x square term to cancel it, right? So you will have a x square term left when you finally simplify. Okay. So example is solved here. Actually you can see this is what you will get, and obviously this is a quadratic equation. Correct? Okay. Next, x into x plus 1 plus 8 equal to x plus 2 into x minus 2. Okay. So here obviously RHS side you can see this is x square minus 4, a plus b into a minus b you have to apply, right? X square minus 4. There is a x square term on the RHS side. And if you see LHS side also there is a x square term, correct? And both gets cancelled. So you are not left with any x square term, right? So this is not a quadratic equation. Okay, let's see. So this is the one we are trying to do. Both sides we have x square term, as I said, gets cancelled. So you are left with x plus 12 equal to 0. This is not in the form of quadratic equation. Okay. Next, third, x into 2x plus 3 equal to x square plus 1. Okay, you have a x square term here. You also have x square term here if you multiply this, but this is 2x square. Okay, 2x square minus x square, which you are still left with 1x square term, right, for this equation. So this is a quadratic equation. Okay, now let's see this one. This is a cube equation. From outside if you see it doesn't look like a quadratic equation, but you look carefully. Okay, you have x plus 2 whole cube. That means you have a x cube term cancelled by the x cube term on the RHS side, correct? And there is no other x square term anywhere. Only from this x plus 2 whole cube you will get a x square term, that is 3x square into 2 basically, that is 6x square you will get. So that cannot be cancelled by any other thing because there is no other x square term. Okay, so this is a quadratic equation because cube term gets cancelled. Okay, so if you see the last one, cube term, this is the one, right? Okay, okay, so this is the final one left on the LHS side, and on the RHS side this is the value. So finally we are left with this is the equation. Okay, this is a quadratic equation. Okay, so it appears that this is not a quadratic equation, but look carefully. We have to see the resultant terms. Okay, not the terms which are on the RHS and LHS, right? If both are same, then they get cancelled. Okay, so these are the examples, and they have shown how to form quadratic equations and how to make sure that you bring all the terms to one side to make sure that you are left with x square term. Then only it's called a quadratic equation. Okay, so let's go to the exercise. Okay, let's see the exercise 5.1. Yeah, check whether the following are quadratic equations or not. Okay, if you see here, you have a LHS side, you have one x square term. If you expand x plus 1 whole square, you get 1 x square term, and other side there is no x square term. So you will be left with the x square term. So it's a quadratic equation. So finally, it is the x square plus 7 equal to 0. It's a quadratic equation. Second one, you have a x square term here and there is no other x square term, so it's a quadratic equation. Okay, bring everything to the same side. That's how you have to do it. Okay, expand it and bring everything to the same side. and see if there is a x square term left or not. Okay, if there is x square term is there, then it's a quadratic equation. Okay, here you have x square term on the LHS side, uh, and there is also x square term on the RHS side. So both will get cancelled. So this is not a quadratic equation. So if you see the final equation is minus 3x plus 1 equal to 0. It's not a quadratic equation. Same way x minus 3 into 2x plus 1. So you have a 2x square on the LHS side and x square on the RHS side. So you are left with a x square term. So it's a quadratic equation. Okay, x square minus 10x minus 3 equal to 0. Okay, so template is same. You have to expand, bring everything to the same side and simplify the terms. Okay. So here you have a 2x square term and x square term. So you will be left with x square term. So it's a quadratic equation. You have a x square term on the LHS side. From the x minus 2 whole square expansion also you get 1x square term. Both will get cancelled. So it is not a quadratic equation. Okay, it's a 7x minus 3 equal to 0. Okay, there is a x cube term here and there is a 2x cube term here. So you are left with the x cube term in the final simplified equation. Okay, so this is not a quadratic equation even though you have a x square term, but the highest power is x cube. Okay, so it's not a quadratic equation. It's a cubic equation actually. Okay, next you have x cube term on the LHS side. You also have x cube term from the x minus 2 whole cube expansion. Both will get cancelled. That's good. And x square term LHS side you have a minus 4x square. RHS side also you have a minus 6x square. So it is a quadratic equation. Finally you are left with 4x square minus 13x plus 7 equal to 0. Okay. Represent the following situation in the form of quadratic equations. Let's see. The area of a rectangle plot is 528 meter square. Meter square. The length of the plot is 1 meter more than the twice its breadth. Okay. We need to find the length and breadth of the plot. Okay. Let breadth of the plot is y. Okay. And length of the plot will become 1 meter more, right? So it will become y plus 1. Okay, given that y into y plus 1 is 528 meter square, right? So if we expand, it will become y square plus y minus 528 equal to 0. This is a quadratic equation for us. Okay, the product of two consecutive positive integers is 306. We need to find the integers. He said product of two consecutive positive integers. So if one is x, other one is x plus 1, right? So let first number equal to x, second number is x plus 1. So product is x into x plus 1 equal to 306. So this will become x square plus x minus 306 equal to 0. This is the quadratic equation we built. Next, Rohan's mother is 26 years old, older than him. The product of their ages after 3 years will be 360 years. We need to find Rohan's present age. Okay. So let the age of Rohan is equal to x, then his mother age is x plus 26, right? This is the current ages. After 3 years, what happens? Rohan's age, product of their ages after 3 years. Rohan's age after 3 years is x plus 3. Mother's age after 3 years is x plus 29, which is equal to 360. So if you expand it, what you will get is x square plus 32x plus 87 equal to 360. Simplify it further, you will get x square plus 32x minus 273 equal to 0. Okay. A train travels a distance of 480 kilometers at a uniform speed. If the speed has been 8 kilometers per hour less, it would have taken 3 hours more to cover the same distance. We need to find speed of the train. Okay. So let speed of the train is x kilometers per hour. Okay. So time to cover 480 kilometers distance is 480 by x. Okay, that is distance by time, distance by speed. Okay. Now time to cover same distance if speed is 8 kilometers less, that is 480 kilometers divided by x minus 8. Okay, right? So which is equal to 480 minus x this time minus 3 hours, right? It takes, uh, sorry, it should be plus 3 hours actually. Okay. So you simplify, you will get a equation from this expansion. It should be plus 3, so you may get a different value here. Okay, but finally you will come up with a correct equation. Okay, once you make it plus 3. Okay, next. Okay, now let's see the how to solve these solutions of quadratic equations. So far we have learnt only how to form the equation. Now we'll see the solution of a quadratic equation by factorization method. There are different methods. First we'll learn the factorization method. Okay. Solution of a quadratic equation by factorization method. Okay. We have learned to represent some of the daily life situations in the form of quadratic equation with the unknown variable x or y or whatever you take. Okay. Now the question is how to find the solution of it. Okay. So consider the quadratic equation 2x square minus 3x plus 1 equal to 0. Okay. If you replace x by 1, then we get which is equal to 0, right? Which means x satisfies this equation, so we will call x is a that 1 is a root of this quadratic equation. Okay, which means 1 is a root of this quadratic equation. In general, a real number alpha is called a root of a quadratic equation ax square plus bx plus c. Okay, if a alpha square plus b alpha plus c equal to 0. Okay, if this is satisfied, then we call alpha as a root of uh, equation, quadratic equation. Okay, or we call it a solution. X equal to alpha is the solution of quadratic equation, or alpha satisfies the quadratic equation, or alpha is the root of a quadratic equation. Okay, so let's see how to do how to find these roots by factorization method. Okay, so there is the equation given here. We need to find the roots of this equation by factorization method. Okay, so we need to split the middle term, that is minus 5 here. Okay, okay, and into two roots basically. Okay, we know from the polynomials that if p and q are the zeros, then p plus q equal to b, right? In the p into q equal to a into c, right? This will be satisfied. Okay, so p plus q should be minus 5. Okay, and p into q should be a into c. Okay, so with this if you see, you need to find two values like this. So let's find all the roots of uh, 6 first. P into q, right? That is 6. 2 into 3, which is 6. All the factors of 6 are 1 comma 6 minus 1 comma minus 6, 2 comma 3 minus 2 comma minus 3. These are the possible factors of 6. Now which of these two will satisfy this equation? P plus q equal to minus 5, it should satisfy. Okay, that way we can split this quadratic equation into factorization. Okay, so from this list, minus 2 minus 3 will satisfy p and q rules, that is p plus q equal to minus 5 and p into q equal to 6. So let us take the middle term, that is minus 5x, and then rewrite it as minus 2x minus 3x. Okay, so this is what we did basically, right? We took the minus 5x, expanded it as minus 2x minus 3x. Now from the first two terms, I can take 2x as common here. Okay, if I take 2x as common, it will become x minus 1 is left. And second two terms, minus 3x plus 3, I will take minus 3 as common. Then I am left with x minus 1 here. And from these two terms, this is first term, this is second term. From these two terms, I can take x minus 1 common. If I take x minus 1 as common, then I am left with 2x minus 3. So I factorized it into product of two numbers, right? So this can be written as 2x minus 3 into x minus 1 equal to 0. Okay. When two numbers product of two numbers is 0, either one of them 0 or both of them are 0, right? So I have two options. Any one of them should be 0 basically, right? Either x minus 1 equal to 0 or 2x minus 3 equal to 0. So option is I have 2x minus 3 equal to 0 or x minus 1 equal to 0. Okay. Now if you simplify, this is a linear equation. If you simplify, what you will get is x equal to 3 minus 2, one option, one solution. Other solution is x equal to 1. Okay. These are the two solutions. Okay. Now be careful whenever you solve this quadratic equation questions, they may ask you to find real roots or integer roots. If they are asking you integer roots for this problem, the solution is only x equal to 1. This is the only integer solution. If it is real solutions, then both are solutions. X equal to 3 by 2 is a solution, x equal to 1 is also a solution. Okay. So just careful what they are asking. Are they asking you to find just roots or integer roots or real roots? What is that? Okay. Now, so this is how you have to do the factorization method and find the solution to the quadratic equations. Okay. There are some exercises given here. Let's solve them and then let's do this section. Find the roots of the following equations using factorization method. Okay, we know the factorization method is factorize this quadratic equation and then find the roots. So x square plus 5x plus 0 plus 6 equal to 0. So if p plus q, we have to separate this into factors. Then p plus q is 5 and p into q is 6. Right? P plus q is 5 and p into q is 6. Okay, so what are the possible values? It has to be 2 into 3 which is 6 and 2 plus 3 which is 5. Okay, so factors that way, x square plus 3x plus 2x plus 6, and you take x common in this, so it will become x into x plus 3. You take 2 common from this, then it will become plus 2 into x plus 3. You take x plus 3 from these two terms, okay, as common, then it will become x plus 2. X plus 3 into x plus 2 equal to 0, which means either x equal to minus 3 or minus 2. Okay, so this is the template we should follow for each of them. Okay, and then solve the problems. X square minus 5x plus 6 equal to 0. The difference is here it is plus x, here it is minus x. Okay, so p plus q is minus 2 minus 3, then it will become minus 5. P into q is minus 2 into minus 3, so it will become 6. Okay, so p is minus 3, q is minus 2, p into q is 6. Okay, so again you do the same way as before. What you will get is x minus 3 into x minus 2 equal to 0, which means x equal to 3 or 3 comma 2. Okay, next, x square plus 5x minus 6 equal to 0. Okay, now if you take this one pq as 2 comma 3, this is satisfied, but 2 into 3 is 6, not minus 6. Okay, so we should take p as 6 and q as minus 1. Okay, then p plus q is 5. Okay, and then p into q as 6 minus 6. Okay, so these are the values you take. Follow the same way, and then you will get x plus 6 into x minus 1 equal to 0, or x equal to roots of this quadratic equation, x equal to minus 6 comma 1. Okay, and next one is x square minus 5x minus 6 equal to 0. X square minus 5x minus 6. Okay, so here p plus q should be minus 5 and pq should be minus 6. So p is minus 6 and q is 1 plus 1. Okay, do it same way, you will get x minus 6 into x plus 1 equal to 0, or roots of the equation are 6 comma minus 1. Okay, now let's check this, try this section. Check whether 1 and 3 by 2 are roots of the quadratic equation 2x square minus 5x plus 3 equal to 0. How do you check roots of whether given number is a root of a quadratic equation or not, or in that case any polynomial? You just substitute and see. Okay. So if f of x equal to 2x square minus 5x plus 3, then f of 1 you substitute and check it is 0, and f of 3 by 2 also you substitute and check it is 0. So 1 and 3 by 2 are the roots of the equation. Okay. Let's do some more examples. Okay. Find the roots of the equation x minus 1 by 3x equal to 1 by 6. X is not equal to 0. Okay. So in this case, if you see, it doesn't look like a quadratic equation, but we need to try to convert into a quadratic equation and then solve the problem. Okay. So if you see here, x minus 1 by 3 x equal to 1 by 6, then you take the LCM here or multiply equation with 3x. Okay, to remove the x term from the denominator. That is the main intention. Okay, remove x term from the denominator. You multiply this equation with 3x. Then what you will get is, and take 6 to the other side. What you will get is 6x square minus x minus 2 equal to 0. Okay, so you converted this equation into a quadratic equation now. Now it is simple. It is same as how you factorize. Okay, minus x can be written as plus 3x minus 4x. So 6x square plus 3x minus 4x minus 2. Okay, right. So then first two terms you will take this as common, 2x plus 1. Okay, and then it will become 3x minus 2 into 2x plus 1. Okay, we factorize here, and the roots are obviously x equal to 2 by 3 and x equal to minus 1 by 2. These are the roots. Okay, you should always verify by substituting this into the equation and see if it is values coming 0 or not. In case you make a mistake, you can correct it. Okay, now next one is find the width of the space for spectators discussed in section 1.1 section. Okay. In section we found that if width of the space for spectators is x meters, then x satisfies the equation. This is the equation. So we need to find just a root of this equation, quadratic equation. Okay. So 45 can be written as plus 47 minus 2x. Okay. Okay, and then x minus 1 is a common term. Okay, so x minus 1 into 2x plus 47 equal to 0 is the uh, final factorization. From that we can say that x equal to 1 or x equal to minus 47 by 2. Okay, now given the problem, the space for the space cannot be negative, right? Space for the spectators cannot be negative. Okay, so which means we should avoid this root. Okay, it cannot be negative, so only possible value is x equal to 1. Okay, this is the only possible value. Okay, let's do the exercise 5.2 now. Yeah, exercise 5.2. Okay, find the roots of the following quadratic equations by factorization method. So I will show you the template here. You follow everything and the same way, and then you can solve the problems. X square minus 3x minus 10 equal to 0, right? So we need to find AB such that AB equal to minus 10, okay, and A plus B equal to minus 3, okay. AB equal to minus 10, A plus B is minus 3, okay. So the options here are, we have 10 factors are 5 and 2. So how do you get minus 3 from 5 and 2? Minus 5 plus 2, right? And minus 5 into 2 is minus 10. Okay. So this equation x square minus 3x minus 10 will become x square minus 5x plus 2x minus 10 equal to 0. Now you take x minus x is common from the first. So x into x minus 5 plus 2 into x minus 5. Take x minus 1 5 as common. So x minus 5 into x plus 2 equal to 0, which means x is equal to 5 or minus 2. These are the roots of the quadratic equation. Okay, hence roots are 5 and -2. You follow the same template for other questions also. Okay, 2x square plus x minus 6 equal to 0. Here, if AB, you should find AB such that a into b equal to -12, a plus b equal to 1. Okay, so a is 4 and b is -3. Okay, now you solve it, then what are the roots you will get? 3 by 2 and -2. Okay, next. Square root of 2x square plus 7x plus 5 square root of 2 equal to 0. Okay, so here a into b should be 5 root 2 into root 2, that is 5 into 2, that is 10. AB equal to 10 and a plus b equal to 7. So a should be 5 and b should be 2. Okay, with this if you do, the roots you will get is minus 5 by square root of 2 and minus square root of 2. Okay, next 2x square minus x plus 1 by 8 equal to 0. First, just to simplify, you multiply with 8 on both sides. What you will get is 16x square minus 8x plus 1 equal to 0. Now AB should be 16 and a plus b should be -8. So the values are -4 and -4. Okay. So this will become 4x minus 1 whole square or x equal to 1 by 4. So roots are, there is only one root basically, that is 1 by 4. Okay, next one is 100x square minus 20x plus 1 equal to 0. Yeah, same way, AB is 100 and a plus b is minus 20. Okay, so this is the values. A is minus 10, b is minus 10. So what you will get is x equal to 1 by 10 as the root. Okay, single root. Now x into x plus 4 equal to 12. If you expand it, it will become x square plus 4x. Take the 12 to the other side, minus 12 equal to 0. Okay, so a is minus 6, b is 2. Okay, you will split it like this. Okay, so what finally you will get is x roots are 6 comma minus 2. Okay, next 3x square minus 5x plus 2 equal to 0. So AB should be 3 into 2, that is 6, and a plus b should be minus 5. Okay, so if you solve, what you will get is x is 2 by 3, roots of x quadratic equation are 2 by 3 comma 1. Next, x minus 3 by x equal to 0. If you multiply both sides with x, what you will get is x square uh, minus 2x, 2x will come to other side, minus 2x minus 3 equal to 0. Okay, so a should be minus 3, b should be 1. Okay, with this if you solve, what you will get, roots are 3 comma minus 1. Okay, you can easily substitute and check. If you substitute 3 here, 3 minus 3 by 3, that is 1 equal to 2, correct. Okay, next 3 into x minus 4 whole square minus 5 into x minus 4 equal to 0. First thing is you expand everything and uh, write it. Okay, alternatively you can call x minus 4 as y. Okay, so it will become 3y square minus 5y minus 12 equal to 0. Okay, now this is a quadratic equation in y, right? You solve it for y and then substitute y value to x. Okay, so for this equation, AB should be minus 9 and plus 4. So you solve it, what you will get is y equal to minus 4 by 3 comma 3, and we know that x minus 4 equal to minus 4 by 3 comma 3 or x equal to 8 by 3 comma 7. Okay, these are the roots of the initial quadratic equation, initial equation given. Okay, next. Okay, 3 into x minus 4 whole square minus 5 into x minus 4 equal to 12. Okay, same way, let x minus 4 equal to y. So the equation will become 3y square minus 5y minus 12 equal to 0. Find out the separation of 5y, that is minus 9 minus 4, and then you will get y values as minus 4 by 3 comma 3. Okay, or x equal to 8 by 3 comma 7. Okay, next. Find the numbers whose sum is 27 and product is 182. Find the numbers whose sum is 27 and product is 182. Okay. Let the first number be two numbers be x comma y, then x plus y equal to 27 and xy equal to 182. Okay. Now you substitute y equal to 182 by x in the first equation. Okay. Replace y. Then this will give x plus 182 by x equal to 27, which means x square plus 182 equal to 27x, or the quadratic equation is x square minus 27x plus 182 equal to 0. Okay, now you solve it same factorization method. Okay, what you will get is x equal to 14 and y equal to 13. Okay, so the two numbers are 13 and 14. Okay, you get two values for x when you solve it, and you substitute it is you get two values for y. Basically they are alternate. Okay, so the two numbers are finally 13 and 14. Next, find two consecutive positive integers, sum of whose squares is given 613. So if the numbers are x and x plus 1, then x square plus x plus 1 whole square equal to 613. This is what is given. You expand it, the equation you will get is 2x square plus 2x minus 612 equal to 0. Okay. So you will find a and b as minus 34 and 36. You can separate the 2x. Okay. And the roots are x equal to 17. This is what we got. Okay, or x equal to minus 18. Okay, in the question if you see they are asking for positive integers, so we should not take minus 18. The only value possible value is 17 and 18. Okay, 17 and 18. Next. Okay, the altitude of a right angle triangle is 7 centimeters less than its base. Okay, altitude of the height is 7 centimeters less than its base. So if you take base as x, altitude is x minus 7. Okay, so which means you apply Pythagoras theorem, it will become x square plus x minus 7 whole square equal to 13 square. Now you just solve it. You got a quadratic equation here, 2x square minus 14x minus 120 equal to 0. You solve the quadratic equation by factorization method. You will get x as minus 5, okay, and 12. 12 or minus 5. Length cannot be negative, so you ignore minus 5. So only possible value is x equal to 12. Okay, so the two sides are 12 and 5. Okay, a cottage industry produces certain number of articles in a day. It is observed that on a particular day, cost of production of each article was 3 more than twice the number of articles produced on the day. If the total cost of production on the day was 90, find the number of articles produced on the and the cost of each article. Okay, so the variables are basically number of articles and cost of each article. Okay, let x be the number of articles produced on that day. So cost of each article is 3 more than twice the number of articles, right? So 2x plus 3, that is, okay, twice the number of articles is 2x, 3 more than that is plus 3. This is the cost of each article. Okay, now the question it is given that the total cost is 90. That means number of articles into cost of each one, that is x into 2x plus 3 equal to 90, right? You expand it, you will get quadratic equation as 2x square plus 3x minus 90 equal to 0. Okay, 90 can be written as uh, I mean 3x can be written as 15 minus 12. So with that, if you factorize, what you will get is x equal to 6. Okay, and you cannot take the other value because it is minus 15 by 2, which is negative. You cannot take. So cost of number of articles are 6 and cost of each article is 2 times 2x plus 3, right? That is 15. Okay, next. Find the dimensions of the rectangle whose perimeter is 28 and the area is 40 square meters. Okay. Let x comma y be the length and breadth of the rectangle. Okay. So 2 into x plus y equal to 28. This is perimeter given, or x plus y equal to 14. And xy, that is area, is 40. Okay. Xy equal to 40. So if you replace y equal to 40 by x, okay, then what you will get is x plus 40 by x equal to 14, or the quadratic equation you will finally get is x square minus 14x plus 40 equal to 0. Factorize it, you will get x as 10 or 4. Okay, x is 10 or 4. Okay, so y is 4 or 10. So basically you got for 10, 4 is the, for 10 length 4 is the breadth, for 4 length 10 is the breadth. Obviously length is greater than breadth, so x equal to 10, and that is length is 10 and breadth is 4. Next, the base of the triangle is 4 centimeters longer than its altitude. If the area of the triangle is 48 square centimeters, find its base and altitude. Okay. Let xy be the base and altitude of the triangle. So x equal to y plus 4. Okay. The base is 4 centimeters longer than its altitude. Okay. Now area of the triangle is half into base into altitude, that is xy by 2, which is 48. And y I will replace as x minus 4. So it will become x into x minus 4 by 2 equal to 48. So the quadratic equation you will get is x square minus 4x equal to 96, or x square minus 4x minus 96 equal to 0. Factorize it. Okay. You will get x as 12 and minus 8. Base cannot be negative, so x equal to 12. So x equal to 12 centimeters and altitude equal to 12 minus 4, that is 8 centimeters. Next, two trains leave a railway station at the same time. The first train travels towards east, west, and second train towards north. The first train travels 5 kilometers per hour faster than the second train. If after 2 hours they are 50 kilometers apart, find the average speed. Okay. Look at the triangle here. The first train is traveling towards west, this side. Second train is traveling towards north. So they are going in the perpendicular direction like this. Okay. At 2x and, okay, first train is traveling 5 kilometers per hour faster than second train. Okay. Okay, if x is the first train speed, then second train speed is x minus 5 kilometers per hour. Okay. Now distance of the first train after 2 hours is 2x. That is here 2x. Okay. From the point, initial point, it is 2x kilometers away. And the distance of second train after 2 hours is 2 into x minus 5. So this is 2 into x minus 5 kilometers away. So this is the distances given here in the diagram. Okay. Now distance between the trains is, we know from Pythagoras theorem, it is square root of 2x square, 2x whole square plus 2 into x minus 5 whole square, which is equal to 50. Simplify, what you will get is the quadratic equation finally you will get is 8x square minus 40x minus 2400 equal to 0. So you factorize it, what you will get is x equal to 20 or minus 120. Of course you can't take negative as speed. So x equal to 20 kilometers per hour. So first train is 20 kilometers per hour speed, second train is 15 kilometers per hour speed. Next, in a class of 60 students, each boy contributed money equal to the number of girls, okay, and each girl contributed money equal to number of boys. If the total money collected was rupees 1600, then how many boys in the class? Okay, total number of boys, let it be x, number of girls is x. So x plus y is 60 because total, and xy into yx equal to 1600, that is given. Okay, that is 2xy equal to 1600 or y equal to 800 by x. You substitute it in the first equation, you will get the quadratic equation as x square minus 60x plus 800 equal to 0. Factorize it, you will get x as 40 or 20. Okay, and for x equal to 40, y equal to 20. For x equal to 20, y is 40. So the total number of boys is either 40 or 20. Next, a motorboat heads upstream a distance of 24 kilometers in a river whose current is running at uh, the trip up and back takes 6 hours. Okay, assuming that the motorboat maintained a constant speed, what was its speed in still water? Okay, let the speed of the boat is x kilometers per hour in the still water. So speed of upstream is plus 3 because 3 kilometers per hour is the stream speed. Okay, and downstream is x minus 3 kilometers per hour. Okay, so time taken to go up and down is 24 by x plus 3 plus 24 by x minus 3, which is total time is 6 hours. Okay, now you take LCM and then solve it. What you will get is quadratic equation as 6x square minus 48x minus 54 equal to 0. Factorize it, you will get x as 9 or minus 1. Speed cannot be negative, so x equal to 9. So speed of boat in still water is 9 kilometers per hour. Okay, let us learn another way of solving a quadratic equation. Okay, solution of a quadratic equation by completing the square. Okay, this is another method. And first thing you should question is why we require another method. Okay, if you see some of the quadratic equations, you cannot factorize easily. Okay, example, you take this quadratic equation here. Okay, x square plus 4x minus 4 equal to 0. So here p plus q should be 4 and p into q should be minus 4. So do you have any number in mind which can satisfy these equations? Right? So it's not possible. I mean, you cannot get two factors of 4 and sum it up to 4 basically. Okay, it's difficult. So such equations, to solve such equations, basically we require a different method to solve them. Okay, now let's learn another method. This is called by solution of a quadratic equation by completing the square. Okay, consider the following situation. Okay, the product of Sunita's age in 2 years ago and her age 4 years hence is one more than twice her parents' age. What is her present age? Okay, let her present age be x years. Okay, her age 2 years ago is x minus 2 then. Okay, and her age after 4 years will be x plus 4. Okay, so x minus 2 into x plus 4 equal to twice her present age. Okay, that is 2x plus 1, and it is 1 more than twice her present age, right? So this is the equation, you form it, and finally this is the quadratic equation, you get it. Okay, uh, isn't it looking easy to solve it without factorization? You don't need a factorization, right? X square equal to 9, which means x is plus or minus square root of 9, that is plus or minus 3. Okay, understand that? Okay, so this is a way of solving a quadratic equation where you can easily get x square equal to some integer and then you get the value of x. Okay, so Sunita's present age is 3 years from this. Okay, now another thing is, consider another quadratic equation which looks like this. Okay, x plus 2 whole square minus 9 equal to 0. Okay, you don't need to expand this x plus 2 whole square and then form another quadratic equation and solve it. Simply what you can do is x plus 2 whole square equal to 9. Okay, which means x plus 2 is plus square root of 9, or x plus 2 is plus or minus 3, which means, okay, x is either 1 or minus 5, right? You have two solutions here, so these are the two solutions. So for such equations you don't require to factorize and solve it. Okay, so this is one method. Okay, now what we try to do is basically whatever is the equation on the LHS side, that is this equation, we try to make it a perfect square. Okay, whatever is required for a perfect square, we add it to this. Okay, and then you add to the RHS side same value. Okay, so then it is easy to solve the problem. Okay, now look at this: x square plus 4x minus 4 equal to 0. Okay, which implies x square plus 4x is equal to 4. Correct. Now I can rewrite this 4x as, okay, x square plus 2 into x into 2. Okay, if you remember a plus b whole square, a square plus 2ab plus b square. So there is a square term, 2ab. Okay, that means b is nothing but 2. So I should have one b square term on the LHS side, correct? So I will add one b square term to the LHS side to make it a square plus 2ab plus b square on the LHS side. Okay, which means b is 2 here, correct? 2ab, b. This is b for me, right? So b is 2, so b square is 4. So I will add 4 to the LHS and 4 to the RHS. Okay, so now my equation becomes x square plus 2 into x into 2 plus 2 square equal to 4 plus 4, which is x plus 2 whole square equal to 8. Right? Now I got into a square form here. That means x plus 2 is equal to plus or minus square root of 8. Correct, which is 2 root 2. Okay, now x will become minus 2 plus or minus 2 root 2. Okay, this is the solution for this quadratic equation. What we did, basically we try to make perfect square on the LHS side by adding or subtracting the constant value. Okay, then equal value will add to the RHS side, then we square root it. Okay, and then get the value of x from that one. Okay, so this is the method of solving quadratic equation by making a perfect square. Now consider the equation. Okay, 3x square minus 5x plus 2 equal to 0. Note that the quotient of x square is not 1 here. Okay, so we divide the entire equation by 3 so that quotient of x square is 1. Okay, so how do you make it perfect square? So this is how we will make it. Okay, x square minus 5 by 3x plus 2 by 3. Okay, now you take the constant term 2 by 3 to the other side. Okay, we took it out. So x square minus 5 by 3x equal to minus 2 by 3, right? Now I am trying to make it 2ab term, 2 into x into 5 by 6. Okay, 5 by 3 I rewrote like this. Okay, now I have x square minus 2ab. So I should add a b square term, that is 5 by 6, correct? 5 by 6 whole square. So I added 5 by 6 whole square to both sides. Okay, now my equation is x minus 5 by 6 whole square equal to minus 2 by 3 minus 2 by 3 plus 25 by 36. Okay, you can see here. Now x minus 5 by 6 whole square equal to this value. I will simplify it. What I get is basically x minus 5 by 6 is 1 by whole square is equal to 1 by 36. So x minus 5 by 6 equal to plus or minus 1 by 6. So x is equal to either 1 or 4 by 6. Okay, or 4 by 6, if you simplify you get 2 by 3 basically. Okay, this is the solution. So I did same thing. I try to make the LHS into perfect square. So since I have a quotient of x square here, which we cannot make perfect square, what I did is basically divided it by the a term a, right? A is the quotient of x square. Okay, so that's how these are the tricks we should learn how to make a perfect square on the LHS side. Okay, let's say another example. It is given here to for us to solve it. We will solve it in the next section. Okay, it is a general quadratic equation, right? Ax square plus bx plus c equal to 0. So you try to solve the same thing, okay, by perfect square method, making a perfect square method. Okay, what you will do first, you will do is divide it by a, correct? Then you will get only x square here. Then try to make 2ab term and then add b square term to both sides and then make it. We will solve it later. You can try it yourself and see the solution. Okay, we will solve it anyway. Find the roots of the equation 5x square minus 6x minus 2 equal to 0 by method of completing the square. Okay, so same way, we'll do it same way. First divided by 5, so you get this value here. Okay, then you try to make this as a 2ab term, so x square minus 2 into minus minus 2 into x into 3 by 5, right? So I will add a 3 by 5 whole square on the both sides. Okay, so 3 by 5 square, if I add, this will become x minus 3 by 5 whole square equal to 2 by 5 plus 9 by 25. If I simplify, this is what I will get. Okay, this is what I get. Okay, then x is equal to either 3 plus square root of 19 by 5 or 3 minus square root of 5 square root of 19 by 5. Okay, let's take another example. Okay, um, find the roots of 4x square plus 3x plus 5 by method of completing the square. Okay, so here also same thing we'll do. Divided by 4 first, then you get 3 by 4 here. Okay, take 5 by 4, the constant term, to the other side, then make it a 2ab term, add 3 by 8 square, which is b square term on both sides. Then it will become x plus 3 by 8 whole square equal to minus 71 by 64. Okay, minus 71 by 64. Okay, now look at this carefully. Okay, look at this carefully. You have a square on the LHS side. Okay, something like y square equal to negative term on the RHS side. Okay, right? So do you have any possibility of getting the value, real value? Because square root of negative value is doesn't exist. It's an imaginary number. It's not real, right? So that means there are some quadratic equations where solution is not possible. Solution is not real. Correct? So there, this we have to note down. Okay, some quadratic equations solution is not real, so which means it is not possible. Okay, so think about it, how if you are trying to solve a quadratic equation, isn't it good that if this quadratic equation has a real solution or not, if you know it before. Okay, so first thing is we should check if the quadratic equation has a real solution or not. If it has a real solution, then proceed with the solving. Correct, so we will learn that as we go. Okay, how to find out if a quadratic equation has a real solution or not, we'll find it out. Okay, let's do this section. Okay, let's do this section. Okay, for our practice, solve the equations by completing the square. Okay, the first one is x square minus 10x plus 9 equal to 0. Okay, so you have x square term. Okay, minus 10x, you can write it as minus 2 into x into 5, right? So you need a 5 square. So minus x square minus 10x plus 25 equal to minus 9 plus 25, which is equal to 16. So now your equation will become x minus 5 whole square equal to 4 square, or x minus 5 equal to plus or minus 4. Okay, so now x equal to either 9 or 1. Okay, this is the solution of this quadratic equation. Okay, now all the problems of solving by completing the square, we should follow the same template. X square minus 5x plus 5 equal to 0. Okay, same thing, you will try to add 5 by 2 as b square term, so 5 by 2 whole square, I will add both sides. What I will get is x minus 5 by 2 whole square equal to 5 by 4, or x equal to 5 by 2 plus square root of 5 by 2, or 5 by 2 minus square root of 5 by 2. Okay, next, x square plus 7x minus 6 equal to 0. Okay, we will try to find what is the missing b term here, that is 7 by 2. Okay, so I will add 7 by 2 whole square, so it will become x plus 7 by 2 whole square equal to 73 by 4, or finally the answer I will get is x equal to minus 7 plus square root of 73 by 2, or minus 7 minus square root of 73 by 2. We have solved several examples and seen how to do uh, find the roots of the quadratic equation by squaring. Now let's take a general quadratic equation and solve it by squaring, and let's see what will be the roots of a quadratic equation. So as we know, general quadratic equation is in the form of ax square plus bx plus c, right? Ax square plus bx plus c, where a is not equal to 0, right? Now first thing what we should do, we should make the x square coefficient as 1. So you divide ax square plus bx plus c by 1 equal to 0 by 1, so this is what you get, right? Now take the constant term to other side. Okay, so x square plus b by ax equal to minus c by a. Then you add the b square term, okay, to make it a whole square, perfect square. Okay, so x square plus b by ax plus 1 by 2 into b by a whole square, which is equal to minus c by a plus 1 by 2 b by a whole square. Okay, we are adding 1 by 2 b by a whole square on the both sides now. Okay, okay, so with this it will become x square plus 2x into b by 2a plus b by 2a whole square, okay, which is equal to the constant term here. So LHS side it is nothing but x plus b by 2a whole square, which is equal to b square minus 4ac by 4a square. Okay, b square minus 4ac, okay, by 4a square. Okay, now if you square root on both sides, what we will get is uh, x plus b by 2a equal to, okay, x plus b by 2a equal to plus or minus square root of b square minus 4ac by 2a. Okay, plus or minus b square minus 4ac by 2a. Okay, so here we should note down that this is inside the square root, correct? This is inside the square root, so this should be greater than 0. So b square minus 4ac should be greater than or equal to 0. Okay, only then this is applicable, right? And x equal to minus b plus or minus b square minus 4ac by 2a. So this is the solution to a quadratic equation. Okay, so we have derived the solution to quadratic equation now. Okay, and this is valid if and only if b square minus 4ac is greater than or equal to 0. Only then it will have a real roots. If b square minus 4ac is less than or equal to 0, you actually don't have real roots, right? Because square root of negative number, we don't have real values, only imaginary values, right? Okay, so b square minus 4ac for that reason is called a discriminant. Okay, we'll see it more next time, nature of roots section. Okay, so what are the two roots of general quadratic equation? Minus b plus square root of b square minus 4ac by 2a, and minus b minus square root of b square minus 4ac by 2a. Okay, if this is the condition, if b square minus 4ac is greater than or equal to 0. Okay, this is the main condition. Okay, so this is called quadratic formula. Okay, let's see some examples. Okay, solve the previous examples by quadratic formula. That's what the question. It was a rectangular plot. Okay, so if the length is 2x plus 1 meters, since area of the rectangular plot is 528 meter square, x into 2x plus 1 is 528 meters, so 2x square plus x minus 528 equal to 0. Okay, so here a equal to 2, b equal to 1, c equal to minus 528. So if you substitute it, what you will get is basically minus 1 plus or minus 65 by 4, which is x equal to 64 by 4 or minus 66 by 4. In other words, x equal to 16 or minus 33 by 2. Okay, so as you know, breadth cannot be negative, so x has to be 16. This is the solution. Okay, now Just look at this question here. We have three methods to solve quadratic equation, right? First one is factorization, second one is by squaring, third one is apply the quadratic formula, right? Which method is good and why? Okay, so if you see the quadratic formula, it's a complex formula, right? Minus b plus or minus square root of b square minus 4ac by 2a. Okay, so for simple equations where you can easily factorize, the best way is to factorize first, right? It's easy to factorize, you factorize. If it is not possible to factorize, then go for formula. Formula and squaring is almost same actually. So this is what we should do. I think each one has a merit when to use. Okay, and if you also see if b square minus 4ac is for a big number of numericals also is complex. So if you can factorize, that is the best method. If you can easily factorize something, if you can't factorize, then go for formula. Okay, let's see some more examples here. Find two consecutive positive odd integers, sum of whose squares is 290. Okay, the first positive odd integer is x. Okay, the second integer will be x plus 2. Okay, so x square plus x plus 2 whole square equal to 290. Okay, now you expand them and simplify. This is the quadratic equation you will get. Okay, so x equal to minus b plus or minus square root of b square minus 4ac by 2. If you substitute all the values correctly, what you will get is x equal to 11 or minus 13. He is asking for positive odd integer, so x is equal to 11. Okay, so if x is 11, then x plus 2, that is the next odd number is 13. So 11 and 13 is the solution. Okay, you substitute and check if answer is correct or not. Okay, next example. A rectangular park is designed whose breadth is 3 meters less than its length. Okay, this is the length x plus 3, then breadth is 3 meters less, so it is x. Okay, its area is to be 4 square meters more than the area of a park that is already made in the shape of a isosceles triangle with its base. Okay, so there is a isosceles triangle here. Okay, and the area of this one is uh, 12. Okay, which is given sorry, area, the altitude is 12. So the area of this triangle, if you take it as y, this is y plus 4 basically. Okay, altitude of this triangle is 12 meters. Okay, find the length and breadth. Okay, now we know that area of a rectangular area is rectangular shape is x into length into breadth, that is x into x plus 3. Okay, meter square. So x square plus 3x meter square, that is, now the base of isosceles triangle is x meters and altitude is 12, right? So area of the triangle is half into x into 12, that is 6x meter square. Okay, now he is given that x square plus 3x is 4 more than triangle area, that is 6x plus 4, right? So our final quadratic equation is x square minus 3x minus 4 equal to 0, right? If you substitute, what we will get is x equal to 4 or minus 1. Lengths cannot be negative, so x equal to 4 is the answer. So x is 4, that is breadth, length is 4 plus 3, that is 7. Okay, x is 4, breadth is 7 meters. Okay, you can verify it anyway. Now next, find the roots of the following quadratic equation using the formula if they exist. Okay, so how do you know if root of a quadratic equation exists or not? Okay, real roots exist or not? By checking the discriminant. Discriminant has to be positive, only then discriminant, if it is discriminant is positive, only then you have the real roots. So x square plus 4x plus 5 equal to 0. Here ABC values are this. So check the discriminant, that is b square minus 4ac, which is equal to 16 minus 20 minus 4. Okay, so this definitely will not have real roots. Okay, so no real root exists for this one. Okay, second one is 2x square minus 2 root 2 x plus 1 equal to 0. Okay, you substitute again ABC you take and find out b square minus 4ac, it is 0. So which is good. That means there is a real roots and it will be only one real root. Okay, it's a perfect square actually. So the real roots are 1 by square root of 2 and 1 by square root of 2. Okay. Okay, let's take more examples. Find the roots of the following equations. X plus 1 by x equal to 3 and x is not equal to 0. Okay. So first one is simple. You just multiply with x on both sides LHS and RHS. What you will get is x square plus 1 equal to 3x, or this is your final quadratic equation. Substitute ABC values. First check if it has a real root or not. So b square minus 4ac is 5. So it has real roots. Okay. So now x equal to 3 plus or minus square root of 5 by 2. Correct? Because discriminant is b square minus 4ac is 5. So square root of b square minus 4ac, right? So the roots are 3 plus square root of 5 by 2 and 3 minus square root of 5 by 2. Okay. Okay. Second problem is 1 by x minus 1 by x minus 2 equal to 3. Okay. X is not equal to 0 comma 2. If x is any of these values, you will get infinity here, right? Undefined. 1 by 0 you will get, which is undefined. Okay. So you multiply this equation with, take LCM or multiply with x into x minus 2 on both sides. What you will get is x minus 2 minus x equal to 3x into x minus 2. That is, finally, this is the equation you will get. 3x square minus 6x plus 2 equal to 0. This is a quadratic equation. Checking the discriminant b square minus 4ac, which is 12. So it is positive. So root exists. Therefore, x equal to 6 plus or minus square root of 12 by 6, which is equal to, these are the values basically. Alright, this is the values of the roots. Okay. Let's check one more example. A motorboat whose speed is 18 kilometers per hour in still water. Okay, 18 kilometers per hour in still water. It takes 1 hour more to go 24 kilometers upstream than return downstream to the same spot. Find the speed of the stream. Okay, let the speed of the stream be x kilometers per hour. Okay, speed of the stream is x kilometers per hour. This is what we need to find. Therefore, speed of the boat upstream is 18 minus x. Obviously, upstream will be speed of the boat minus stream speed, right? So this is the upstream speed, and the downstream will be 18 plus x. Okay. So time taken to go to upstream is distance by speed, which is 24 by 18 minus x. Time taken for downstream is 24 by 18 plus x, and the difference is 1 hour. That's what is given, right? It takes 1 hour more for upstream because speed is less. Resultant speed is less. So this is the equation. If you simplify it, what you will get is, this is the quadratic equation. Okay, x square plus 48x minus 324 equal to 0. Substitute ABC values into the quadratic formula. What you will get is x equal to, okay, minus 48 plus or minus 60 divided by 2, which is equal to 6 or minus 54. Speed cannot be negative, right? So x is 6. So the speed of the stream is 6. That means, right? Okay. Now there is the exercise section. Let's see the exercise now. Okay, exercise 5.3. Find the roots of the following quadratic equations if they exist. Okay. So let's first discuss first problem very detailed. So that template we will set and we'll follow the same for other problems. 2x square plus x minus 4 equal to 0. Okay. So root of the quadratic equation we know, minus b plus or minus square root of b square minus 4ac by 2a. Okay. Now check discriminant. Okay. D equal to b square minus 4ac, which is equal to 1 minus 4 into 2 into minus 4, that is 33. Okay, it is positive, so roots exist, correct? The roots are x equal to minus 1 plus or minus square root of b square minus 4ac is this value same d, correct? So 33 divided by 2 into 2. Okay, that is these two are the roots of the quadratic equation. Okay, minus 1 plus square root of 33 by 4 minus 1 minus square root of 33 by 4. Okay, next 4x square plus 4 root 3 x plus 3 equal to 0. Same thing. Okay, discriminant is 0, so roots exist. Okay, and the root is square root of 3 by 2. Okay, 5x square minus 7x minus 6 equal to 0. Okay, discriminant is 169, which means it's positive, roots exist. Okay, and the root is 2 and 3 minus 3 by 5. Okay, next. X square plus 5 equal to minus 6. Okay, which you can rewrite it as x square plus 6x plus 5 equal to 0. Discriminant is 16. Okay, so root exists, that means positive roots. Okay, and the roots are 1 comma 1 by 5. Okay, next. X minus 1 by x equal to 3 and x is not equal to 0. Okay, we can rewrite x minus 1 by x equal to 0 as x square minus 1 by x equal to 3 or x square minus 3x minus 1 equal to 0. Okay, now same thing we will apply. Okay, discriminant is 13, so root exists. Okay, two real roots will be there, and they are 1 plus square root of 3 by 2 and 1 minus square root of 3 by 2. Okay, 1 by x plus 4 minus 1 by x minus 7 equal to 11 by 30. Okay, same thing, you take LCM and then simplify this. What you will get is 11 into x plus 4 into x minus 7 equal to 30x minus 11. Simplify further, the equation is x square minus 3x plus 2 equal to 0. X square minus 3x plus 2 equal to 0. Discriminant is 1, which means root exists, two real roots, and they are 3 plus square root of 1 is 1. Okay, I made a mistake. Okay, 3 plus 1, that is 4 by 2, 2, and 3 minus 1, that is 2 by 2, that is 1. So 2 and 1 are the roots of this equation given. Okay, if the sum of reciprocals of Rahman's ages in years is 3 years ago and 5 years from now is 1 by 3, find his present age. Okay, so let's Rahman's age is x, present age. So 3 years ago it is x minus 3, 5 years from now it is x plus 5. Okay, so he's telling sum of these two, sum of reciprocals basically is 1 by x minus 3 plus 1 by x plus 5 equal to 1 by 3. Okay, so which implies 3 into x plus 5 plus x minus 3 equal to x minus 3 into x plus 5. Simplifying the quadratic equation, you will get is x square minus 4x minus 21 equal to 0. Okay, x square minus 4x minus 21 equal to 0. Now you apply same template, discriminant and everything. Okay, check it, and then x equal to what the values you will get is 7 and minus 3. These are the roots of this one. Okay, so minus 3 cannot be age, right? So 7 is the answer. Okay, next. In a class test, the sum of Moulika's marks in mathematics and English is 30. If she got 2 marks more in mathematics and 3 marks less in English, the product of their marks would have been 210. Find her marks in 2 subjects. Okay, so let's Moulika's marks in maths is x and in English it is y. Okay, so x plus y is 30, that's what is given. And if she gets 2 marks more in maths and 3 marks less in English, and product of that x plus 2 into y minus 3 equal to 210. Okay, now substitute y equal to 30 minus x in equation 2. Okay, what it will become is x plus 2 into 30 minus x minus 3 equal to 210. 30 minus x minus 3 equal to 210, or if you simplify the quadratic equation, you will get is x square minus 25x plus 156 equal to 0. So again apply the same template. X equal to, you will get two possibilities, 13 and 12. These two are possible. Okay, if x equal to 13, y, that is marks in English, is 17. If x equal to 12, then marks in English is 18. Okay. Okay, so marks in maths and English are 13 comma 14 or 12 comma 18 respectively. Okay, next. The diagonal of a rectangular field is 60 meters more than the shorter side, and longer side is 30 meters more than the shorter side. Find the sides of the field. Okay, length of rectangular field equal to x and the breadth is x minus 30. Okay, diagonal of the field is square root of x square plus x minus 30 whole square, which is equal to x minus 30 plus 60. Okay, that is equal to x minus 30 plus 60, that is equal to x plus 30. Okay, squaring on both sides, what we will get is this one. Okay, then x square equal to 120x, this is what you will get, and x is equal to 120. Okay, so length of the field is 120 and breadth of the field is 90 meters. Next. Yeah, the problem is here, the difference of squares of two numbers is 180. The square of the number is 8 times larger, 8 times the larger number. Find the two numbers. Okay, let the smaller number equal to x and bigger number equal to y. Okay, now x square equal to 8y, that's what is given. Square of the smaller number is equal to 8 times the larger number. Okay, then difference of squares of two numbers, that is y square minus x square, because y is greater than x, y square minus x square equal to 180. Okay, now we can replace x square equal to 8y, so it will become y square minus 8y minus 180 equal to 0. This is a quadratic equation in y. So you apply same thing again. So y is equal to, you have two values, that is 18 and minus 10. Okay, y is equal to 18 and minus 10. These are the two roots we got, but length cannot be negative. Okay, and hence we have to take only the positive value, that is for y equal to 18. Okay, for y equal to 18, x is 12. Okay, we cannot take negative value for the length, so that's not real. Okay, so the smaller number is 12 and bigger number is 18. Next. A train travels at 360 kilometers at a uniform speed. Okay, and the problem is stated is the speed had been 5 kilometers uh, less, would have taken, if the speed had been 5 kilometers per hour more, would have taken 1 hour less for the same journey. Find the speed of the train. Okay, so let the speed of the train be x kilometers per hour. Time taken to cover 360 kilometers distance with x speed is 360 by x hours. Okay, time taken to cover 360 kilometers distance with x plus 5 speed, 5 kilometers more, then 360 by x plus 5 hours. Okay, the difference of these two is 1 hour. Okay, so 360 by x minus 360 by x plus 5 equal to 1. Simplifying, the equation you get is x square plus 5x equal to 1800, or x square plus 5x minus 1800 equal to 0. Apply the same quadratic formula, and then what the value you will get is 40 and minus 45. Speed cannot be negative, so x is equal to 40 kilometers per hour. Okay, next. Okay, the problem is stated here. The time taken by bigger tap to fill the tank is x hours. Okay, let the time taken by the bigger tap to fill the tank is x hours. Time taken by smaller tap to fill the tank is equal to y hours. Okay, so y minus x difference is given equal to 10. Okay, because the larger diameter tap of larger diameter takes 10 hours less than the smaller one, right? So y minus x equal to 10. Okay, now part of the tank bigger tap fills in 1 hour is 1 by x, part of the tank smaller tap fills in 1 hour is 1 by y hours. Okay, and the difference is part of the tank two taps together can fill in 1 hour is given as uh, 1 by 9 3 by 8, that is nothing but 8 by 75. Okay, that is equal to 1 by x plus 1 by y, two taps, right? Sum of two taps 1 hour work. Okay, okay, and y is equal to x plus 10, so replace y with x plus 10. The quadratic equation you will get is uh, here. Okay, 8x square minus 70x minus 750 equal to 0. 8x square minus 70x minus 750 equal to 0. So again apply the quadratic formula. The values you will get is x is equal to 15 hours. The negative one you can ignore. Okay. So time taken by smaller tap to fill the tank is 25 hours. And the time taken by larger tap to fill the tank is 15 hours. Okay. Read the question. Speed of the express train is x kilometers per hour. Speed of the passenger train is y kilometers per hour. Obviously, x is greater than y. So x minus y equal to 11 kilometers per hour. Okay. Now 130 kilometers distance covered by small passenger train is 132 by y minus 132 by x is express train time taken by the express train, which is equal to 1. Okay, 1 hour, right? So that implies 132 into 1 by x minus 11 by 1 by x equal to 1. Okay, you simplified the quadratic equation you will get is x square minus 11x minus 1452 equal to 0. Okay, now you can factorize and see this looks easy to factorize actually 1152. Okay, so minus 44 and plus 33. So you will get x minus 44 into x plus 33 equal to 0. X equal to 44 or minus 33. Speed cannot be negative, so x equal to 44. So speed of express train is 44 kilometers per hour and speed of passenger train is 33 kilometers per hour. Okay, next. Okay, read the question. Okay, side of first square is x meters, side of second square is y meters. So 4 into x minus 4x minus 4y equal to 24 meters, or x minus y equal to 6. Okay, 4x is perimeter of each square, 4x and 4y. Okay, then areas x square, sum of areas is x square plus y square equal to 468. Okay, so x square plus y I am replacing with x minus 6, so x minus 6 whole square equal to 468, and the final quadratic equation you will get is 2x square minus 12x minus 432 equal to 0. Okay, and I'll just use factorization method because 432 into 2 is simple to make factors. So you will get 36 x minus 36 and x plus 24 as factors. So that means x is equal to 36 or minus 24. length cannot be negative, hence x equal to 36. So side of the first square is 36 meters, side of the second square is equal to 36 minus 6, that is uh, 30 meters. Next. Okay, read the question. Okay, as told initially, the distance covered by projectile motion is a quadratic equation. So that is what is given here, 12 plus 17t minus 5t square. It is a quadratic equation in time variable t. Okay. So this is the equation which they have given. So what we need is find the time taken by the object to touch the ground. When the object touches the ground, the distance is basically 0. Okay, it goes up and comes back to the same point. So distance is s is equal to 0. So when s is equal to 0, you have two possibilities, right? You will get one is initial time, and then when the finally the object has reached, so how much time. So t you will get here in a quadratic equation, 5t square minus 70 to minus 17t minus 12 equal to 0. You apply quadratic formula, what you will get is t is equal to uh, 40 by 10, that is 4, or minus value. So negative value we will ignore. It is not minus of minus, it is just minus of 6 by 10. So okay, so you will ignore the negative value. So t is equal to 4 seconds. So time taken cannot be negative, so only take the positive value, t equal to 4 seconds. So this is the time the object will once it is thrown, it takes 4 seconds to reach the ground back. Okay. Okay, read the question. If a polygon of n sides has 1 by 2 n into n minus 3 diagonals, how many sides are there in a polygon with 65 diagonals? Is there a polygon with 50 diagonals? There are two questions. Okay, number of diagonals in a n-sided polygon is given n into n minus 3 by 2. Okay, n into n minus by 2 equal to 65. So first let's check how many sides are there in the 65 polygon, 65 diagonal polygon. Okay, so simplifying the quadratic equation you will get is n square minus 3n minus 130 equal to 0. I just used factorization method. You can use anything you want. Okay, so it will become n minus 13 into n plus 10 equal to 0, or n is equal to 13 or minus 10. Number of sides cannot be negative, so n is equal to 13. So number of sides in 65 diagonal polygon is 13. Okay, and the second question, n into n minus 3 by 2 equal to 50. Let's check if there is a polygon exists. Okay, so n square minus 3n minus 100 equal to 0. This is the final quadratic equation you will get in the variable terms of sides. Discriminant is b square minus 4ac. So 3 square minus 4 into minus 100, which is 409. This is positive, so there exists. Oh, 409 is not a perfect square, so you don't get a, it's not a perfect square, so you will get some real value in fractions, and number of sides cannot be fraction. So exactly 50 diagonal polygon you don't get. Okay, the difference of this question from the previous ones is here we are expecting a integer solution. Okay, because number of sides cannot be fraction, right? So we are expecting a integer solutions, even though there is a real solution exists, but we don't want a fractional solution here. So only integer values is what we are looking at. Since there is no integer solution with this discriminant 409, there is no polygon with 50 diagonals. Okay, uh, just check the difference between this question and the rest of the questions. Okay. Okay, let's see nature of roots next. Nature of the roots. Okay, so in this section what we will learn is how the roots are, uh, what type of roots are there, how when they represent on the graph, how they look like the graph. Okay, and this properties of this quadratic equation we'll learn here. In the previous section we have seen the roots of quadratic equation, that is this is the quadratic equation, right? So ax square plus bx plus c equal to 0 is this one, right? Minus b plus or minus square root of b square minus 4ac, okay, divided by 2a, okay. Now, if b square minus 4ac is greater than 0, then we get a real roots, two distinct real roots, correct? Because the term here has some value, okay, and you have plus and minus, so you will get two different terms, right? Okay, these are the zeros of those points basically. If you draw them on the graph, how they look like is basically they cut the x-axis at least two times, okay. You see here either both are negative here in this case, correct? In this case both are negative, so x-axis it is actually intersecting with the x-axis at 2 points. This parabola is the graph of quadratic equation x square plus bx plus c equal to 0, okay. If it has two distinct roots, then possibility is that both are negative, okay. In this case the y value here uh, is the solution, okay. You can have one negative, one positive, or both are positive, okay. So graphs can look something like this one if you have two distinct roots, okay. If b square minus 4ac equal to 0, okay, that means your roots are basically minus b by 2a, that's it, there is only one root, correct. And the parabola looks like this. It will intersect with the x-axis only at one point, only at one point, either it is 0 or negative or positive, okay, but you will have only one value. If the discriminant, that is b square minus 4ac, is less than 0, that means square root of negative value has no meaning, right? Only imaginary. So it don't have any real roots. That means this parabola don't intersect with x-axis at all, okay. It won't intersect with the x-axis at all. So the graph looks like this, either on the third quadrant or across the first and third quadrant, or here, or it can be anywhere, okay. It won't cut the x-axis basically. It can't be below, because if you it is down, then you extend it basically, it will anyway cut the x-axis, but it can be a reverse parabola down, okay. So this is the three types of roots we can actually think of depending on the discriminant b square minus 4ac value, okay. And when you draw the graph, they look something like this, okay. So b square minus 4ac, this is the reason is called a discriminant, okay. Discriminant it's called, okay. And as we know, it has two distinct real roots if b square minus 4ac is greater than 0, two equal roots if it is b square minus 4ac is equal to 0, no real roots if b square minus 4ac is less than 0. So this is the one most important point to note down, okay. Now let us find the discriminant of quadratic equation 2x square minus 4x plus 3 equal to 0, okay. Then hence find the nature of its roots, okay. B square minus 4ac equal to minus 8, okay. So it don't have real roots. The given equation has no real roots, that means, right? Okay, next. A pole has to be erected at a point on the boundary of a circular park of diameter 13 meters in such a way that difference of its distance from two diametrically opposite fixed gates A and B on the boundary is 7 meters. Okay. On the diameter you have two gates A and B here. Okay. Obviously it's a diameter, so it is given as 13 meters distance. Diameter is, okay. And a pole has to be erected on the circle, perimeter of the circle basically, okay, so that it has to be up, difference of distances from two gates should be 7 meters. That means if distance from B is x, then distance from A should be x plus 7, okay. Now we know that it's a diameter subtends a right angle triangle on the perimeter of the circle, okay. So this is 90 degrees, So this will be ABP will be a right angle triangle. So you apply the Pythagoras theorem. What we will get is x plus 7 square plus x square equal to 13 square. Okay, x plus 7 square plus x square equal to 13 square. So you simplify, this is the quadratic equation you will get. Okay, or further you can divide it by 2. This is the quadratic equation. Okay, now the discriminant part, b square minus 4ac equal to 289. So this is good actually. It is positive, so we will have two real roots and greater than 0, right? So now the roots are minus 7 plus or minus 273. Okay, minus 7 plus or minus square root of 289 divided by 2, and which is equal to minus 7 plus or minus 17 divided by 2, or x is equal to 5 or minus 12. These are the two values. Distance cannot be negative, right? Distance only has to be positive. So x equal to 5 is the option. So from one gate it is 5 meters distance, and the other gate it is 12 meters distance. Okay. Now explain the benefits of evaluating discriminant of a quadratic equation before attempting to solve it. What does it the value signify? So we already learned it gives us what kind of roots basically the quadratic equation has. Either it has two positive roots, two real roots, or one real root, two distinct real roots, or two identically same real roots, or imaginary roots. Okay, or no roots basically. So based on that, we can actually continue to find the roots of the quadratic equation. If it is negative, discriminant is negative, you need not find the roots, right? Because there is no root exists for that. Okay. Write three quadratic equations on having two distinct real roots, one having no real solution, one having exactly one real solution. Okay. Yeah, this is very easy. You take two distinct roots, you call it x minus 2 into x minus 4 equal to 0. You actually multiply and make the quadratic equation. Okay, that will become like x square minus 6x plus 8 equal to 0. And exactly one real root, how you will get? You just do a square actually. Okay, x minus 5 whole square or x plus 10 whole square. Okay, these are all one real root. And the no solution is where you should be careful. Make sure that a, b, c, write a equation with b square minus 4ac comes negative. Okay, so b should be bigger, a and c should be smaller. So it should be something like x square minus 6x plus 1 equal to 0. Okay, sorry, other way, x square plus x plus 6 equal to 0. Okay, something like that. Okay, you can easily write it. Now another example we'll try. Find the discriminant of equation. Okay, 3x square minus 2x plus 1 by 3 equal to 0. Hence find the nature of roots and find them if they are real. A equal to 3, b equal to minus 2, and c equal to 1 by 3. So discriminant is 0. That means it has real roots and only one unique real root, right? So that will be minus b by 2a. So that is 1 by 3. Okay. Let's see the exercise 5.4 now. Let's do the exercise 5.4. Find the nature of the roots of the following quadratic equation. If a real root exists, find them. Okay. So let's follow a template and then apply it same to all the problems. 2x square minus 3x plus 5 equal to 0. Discriminant is b square minus 4ac, which is equal to minus 31 you get. So it's negative, so real roots doesn't exist for this equation. Next, 3x square minus 4 square root of 3x plus 4 equal to 0. Here discriminant is b square is 16 into 3 minus 48, which is equal to 0. So real root exists and it is nothing but 2 square root 3 by 3. Okay, third, 2x square minus cx plus 3 equal to 0. Discriminant is 12, so root exists and it is 6 plus 2 root 3 by 4, 6 minus 2 root 3 by 4. Okay. Next, 2x square plus kx plus 3 equal to 0. Here the question is we should have two equal roots. Okay. And two equal roots are possible if discriminant is 0, right? So b square minus 4ac, which is equal to k square minus 4 into 2 into 3, or k square minus 24 equal to 0, which means k should be plus or minus square root of 24. Uh, for these k values, this quadratic equation will have two equal roots. Okay. Next, kx into x minus 2 plus 6 equal to 0. So you can write it as kx square minus 2kx plus 6 equal to 0. And of course, two equal roots are possible if b square minus 4ac is 0. So that is nothing but 4k square minus 24k, which is equal to 0. So either k equal to 0 or k equal to 6. Okay. And it is given that k is not equal to 0. So you ignore the k equal to 0 value. So the possible value is k equal to 6. Next. Is it possible to design a rectangular mango grove whose length is twice its breadth and the area is 800 meters square? If so, find its length and breadth. Okay. Breadth of the grove is x and it is given length is twice, so length of the grove is 2x. So area of the grove is length into breadth, which is 2x square equal to 800 meters square. So x square equal to 400 or x equal to 20 meters. Just I am ignoring the negative minus 20. So it is possible to design a groove with breadth as 20 meters and length as 40 meters and the area is 800 meters square. Next. The sum of the ages of two friends is 20 years. 4 years ago, the product of their ages in years was 48. Is the above situation possible? If so, determine their present ages. Okay. Let x comma y are the current ages of the friends. So x plus y is 20 as given. 4 years ago, their ages will be x minus 4 and y minus 4. So it is given that x minus 4 into y minus 4 equal to 48. Okay. So x minus 4 into y replace with 20 minus x. So 20 minus x minus 4 equal to 48. Or the quadratic equation finally we get is um, x square minus 20x plus 112 equal to 0. So discriminant is minus 48, which means this quadratic equation does not have a real roots. So a situation given is not possible with the ages. Next. Is it possible to design a rectangular park of perimeter 80 meters and area 400 meters square? If so, find the length and breadth. Comment on your answer. Okay. Let x comma y be the length and breadth of a park. Okay. Uh, so that means the perimeter is 80, it is given. So 2 into x plus y equal to 80 and or x plus y equal to 40 and x into y equal to 400. Okay. So I'll replace y value with 40 minus x. Okay. Here y value I am replacing with 40 minus x. So x into 40 minus x equal to 400. So the quadratic equation finally I get is x square minus 40x plus 400 equal to 0 and the discriminant is 0, which means we have one value for this one and the solution for x is 20. Okay. So length is 20, length of the park is 20 and incidentally breadth of the park also 20, which means it is a square actually. It's a square shaped park. So the question is they're asking to design a rectangular park. Okay. So if it is a rectangular park then but answer we got is a square park, but you can call square as rectangle. Okay. Square is also a rectangle, just the difference is length and breadth are same, otherwise it has all the properties of rectangle. So rectangle is a subset of square with respect to the properties, right? So uh, it is possible to design a park with given conditions, rectangular park, just that it is a square park, not rectangle. Next. Okay, let's do the optional exercise also. Some points are plotted on a plane such that any three of them are non-collinear. Okay. Each point is joined with all remaining points by line segments. Find the number of points if the number of line segments are 10. Okay. So just read the question carefully. There are multiple points on a plane. Okay. And there are no 3 points which are collinear. Okay. That means you are actually drawing a polygon. Okay. Only in polygon you don't have 3 points which are collinear, right? So you are drawing a n-sided polygon, okay, and in an n-sided polygon, okay, number of lines you can draw is basically one way. If you already know these combinations, permutations and combinations, it is NC2. You need 2 points to draw a line. So from n points you can draw n into n minus 1 by 2. Okay, but if you don't know this by this time, you can derive this equation very easily. Okay, you have n points on a plane. How many lines you can draw? This is first point. I can draw n minus 1 lines to all other points, right? So first one is n minus 1. And I take the second point. I can draw n minus 2 lines to all other points because to the first point already line is drawn. Okay, so I don't need to draw again. So I get n minus 2. Okay, and then from third point I will do n minus 3, like that up to the last point where I don't need to draw any line. Okay, so total you will get is basically n minus 1 plus n minus 2 up to 1. Basically that's the number of lines you can draw with n points. Okay, so this is nothing but a series sum of first n integer problem, just that it is sum of n minus 1, first sum of first n minus 1 integers, which is equal to n minus 1 into n by 2, okay, which is same as NC2. Okay, now it is given that number of lines drawn are 10. So n into n minus 1 by 2 equal to 10, or the quadratic equation you get in n is n square minus n minus 20 equal to 0. You can factorize. It looks very simple, right? Minus 20 can be minus 5 and 4. So I just factorize it. The solutions I will get is n minus 5 into n plus 4 equal to 0, or n equal to 5 or minus 4. Ignore the negative part because number of points cannot be negative. So number of points on the plane is 5. Okay, hope you understood this. Most important thing is to get to the quadratic equation, because after that it is very simple. You have multiple ways to solve them. So most important thing is to read the question carefully and come to a quadratic equation correctly. Okay, next. A two-digit number is such that the product of its digits is 8. When 18 is added to the number, the digits interchange their places. Determine the number. Okay. Let the digits of the number be x comma y. So that means product of those digits is 8, right? So x into y is equal to 8. When 18 is added, the number gets reverse. Okay. So the number with the digits x comma y is 10x plus y. Okay. The number with the digits interchanged is 10y plus x. Okay. So 10y plus x equal to 10x plus y plus 18. Okay. And then now substitute y equal to 8 by x from this equation. Okay, xy equal to 8, right? So with that you get the quadratic equation 10x square plus 18x plus 8, okay, equal to 80 plus x square. Sorry, the final quadratic equation you will get is x square plus 2x minus 8 equal to 0. Okay, now this can be factorized easily. Okay, so I'll write it as 4 and minus 2. Okay, so you will get x plus 4 into x minus 2 equal to 0, or x equal to 2 comma minus 4. Okay, digit cannot be negative, so only possibility is x equal to 2. So x is 2 and y will be 4. So the number is 24. Next. A piece of wire 8 meters in length is cut into two pieces and each piece is bent into a square. Where should the cut in the wire be made if sum of the areas of those squares is to be 2 meters square? Okay, so uh, you have a wire of 8 meters length. It is cut into two pieces. Okay, let the two pieces be x and y meters in length. Okay, so x plus y equal to 8. That is the total length of the wire. Okay, now two squares are formed with these two wires of length x meters and y meters. That means what is x meters? For the first square, it is the perimeter of the square. For the second square, y is the perimeter of the square. Okay, so the side of the square with perimeter x equal to x by 4, and similarly, second one y by 4, right? So area of the first small square is x square by 16. Area of second small square is y square by 16. Okay. Now x square by 16 plus y square by 16 equal to 2. That's what is given. And I'll replace y with 8 minus x from here. Okay, x plus y equal to 8. So with this, I'll form my quadratic equations, which is x square minus 8x plus 16 equal to 0. This is my quadratic equation. Okay, I can easily see this is in the a minus b whole square form. So x minus 4 whole square, which is equal to 0, or x equal to 4 meters. So that means y is also 4 meters. Okay, so the wire should be cut in the middle. Okay, next. Vinay and Praveen working together can paint the exterior of a house in 6 days. Vinay by himself can complete the job in 5 days, less than Praveen. How long will it take Vinay to complete the job by himself? Okay, Vinay can finish the job in x days, let's say. So in 1 day he can finish 1 by x work. Praveen can finish the work in y days. In 1 day he can finish 1 by y work. Okay, now it is given that of course Vinay takes less time than Praveen, so y minus x is equal to 5. Okay, and 1 by x plus 1 by y equal to 1 by 6, because both of them together can finish in 6 days. So in 1 day they can finish 1/6 of the work. Okay, so 1 day, 1 day work of Vinay, 1 day work of Praveen, sum it, then that is equal to 1 by 6. Okay, so what you will get is basically 6 into x plus y equal to xy. Okay, now if you simplify this, what you will get, replace y value. Okay, 6x plus 6 into 5 plus x equal to x into 5 plus x. Okay, that is finally the quadratic equation you will get is x square minus 7x minus 30 equal to 0. Okay, now you can factorize it, x minus 10 into x plus 7 equal to 0, or x equal to 10 or x minus 7. The number of days cannot be negative, so x is equal to 10. So Vinay can complete the work alone in 10 days. Okay, now okay, show that the sum of roots of quadratic equation is ax square plus bx plus c equal to 0, where a is not equal to 0, is minus b by a. Okay, this is we know from the polynomials. This is sum of zeros of a polynomial. Quadratic polynomial is minus b by a, correct? So we just want to prove it. Now here, let's see. This we have done there already, but let's do it again. Let p and q be the roots of the quadratic equation. So x minus p into x minus q equal to 0. So that makes it x square minus of p plus q into x plus pq equal to 0. Okay, now this is the given equation, right? Okay, to compare easily with this equation, you divide ax square plus bx plus c equal to 0 by a. That will give us x square plus b by ax plus c by a equal to 0. Now you compare the sum of roots. Sum of roots is p plus q is here, right? So minus p plus q equal to b by a, which means p plus q equal to minus b by a. Okay, that is sum of the roots. Okay, the next question is same way, product of the roots is asking, prove that it is c by a. Same way, you just compare these two. pq is product of roots, which is equivalent here is c by a. So pq equal to c by a, or product of roots equal to c by a. Okay. Okay. If the sum of the fraction and its reciprocal is 2 16 by 21, find the fraction. Okay. Let the fraction be 1 by x and the number is x. So x plus 1 by x equal to 2 16 by 21 or 58 by 21. Now you form the quadratic equation here. This is nothing but 21x square minus 58x plus 21 equal to 0. Okay. So you can make it 49 into 9, basically 21 into 21. Okay. So that will give us 3x minus 7 into 7x minus 3 equal to 0, or x is equal to two values will get. One is 7 by 3, other one is 3 by 7. Okay, and 1 by x will be 3 by 7 or 7 by 3. Okay, so if you look at both answers are possible for the fraction, but just to give proper fraction, it is 3 by 7. Okay, 3 by 7 is a proper fraction, and the other one is basically 7 by 3 is improper fraction. You can call anything, but yeah, one of them is the fraction basically. Next. Yeah, what we have discussed in this chapter is one is standard form of quadratic equation in variable x is ax square plus bx plus c equal to 0, where a, b, c are real numbers and a is not equal to 0. This is the definition of a quadratic equation. Okay. A real number alpha is said to be root of quadratic equation if it satisfies a alpha square plus b alpha plus c equal to 0. Okay, we can factorize alpha x square ax square plus bx plus c into product of two linear factors, then the roots of the quadratic equation we can find. Okay, the quadratic equation can also be solved by method of completing the square. Okay, this is the second method of finding. Third method is directly apply the quadratic formula, which is for ax square plus bx plus c equal to 0, the formula x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay, you will get real solution only if and only if b square minus 4ac, that is discriminant, is greater than or equal to 0. Okay, now there are nature of roots can be determined by discriminant. Okay, for ax square plus bx plus c, the discriminant is b square minus 4ac. Okay, for two distinct real roots, b square minus 4ac is greater than 0. Two equal roots, b square minus 4ac is equal to 0. For no real root, if only imaginary roots, then b square minus 4ac is less than 0. So this is what we learned, and we solved several problems. Hope I think most of the equations and polynomials we have done with actually. This is very base to most of the mathematics and physics problems. So don't make mistake here. Concept is very simple. You have very few formulas to remember. Even if you don't remember, you can derive easily. You should know the method of deriving, and these are the very basic concepts. So you should remember the formulae. Okay. Hope we will again come up with the next chapters. Uh, yeah. Until then, keep solving the problems.